Suppose we write down natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, up to infinity. Natural numbers are for counting the whole things, like persons, people, persons cannot exist fractionally. So natural numbers are always integers, whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. If there is no person, there is no zero also. So natural numbers, set of natural numbers doesn't contain zero in itself. Any two neighboring natural numbers differ by 1. For example, 13, 14, 14, 15, 15, 16. We go on adding 1 by 1. These are serial natural numbers. Now, in serial natural numbers, we have 1, 2, 3, 4, 5. 1 is odd, 2 is even, paired 1. 3 is odd, unpaired. 4 is even, paired 1. 2 plus 2. 5 is odd, unpaired. 6 is even, 3 plus 3. 2 plus 2 plus 2. Like that, the natural numbers are odd, even, odd, even, odd, even, differing by 1. In that set, if we consider consecutive odd numbers, before that, if we mark perfect squares, 1 is a perfect square, next, second is the perfect square 4, third is the perfect square 9, fourth perfect square is 16, fifth perfect square is 25, sixth perfect square is 36, like that. So, numbers between two perfect square numbers are not perfect squares. Their roots are not integers. Root of 9 is 3, root of 16 is 4. But the numbers between 9 and 16 will have roots between 3 and 4, which is not an integer, the whole number. So, numbers between two perfect squares, let us try to find out how many are the numbers between two perfect squares. So, consider 1 square and 2 square. 1 square is 1, 2 square is 4. The numbers between 1 and 4 are 1, 2, 3, 4, that is 2 and 3. There are two numbers between square of 1 and square of 2. Similarly, square of 3 and square of 4. Square of 3 is 9. Then the natural numbers are 10, 11, 12, 13, 14, 15 and 16. So, this number 9 and this number 16 are perfect square numbers. Their roots are integers. Here 3, here 4. So these are not perfect squares. How many are there? Here we see that 1, 2, 3, 4, 5, 6. There are 6 natural numbers between perfect square of 4 and perfect square of 3. Now, find the difference between perfect square of higher number than the perfect square of previous number, that is square of 4 minus square of 3. Square of 4 minus square of 3, that is 16 minus 9, that gives us 7. This is 16, this is 9. This gives us 7. And 7 is 1 less than, and 6 is 1 less than 7. As there are 6 numbers here between 9 and 16, these 6 numbers are less by 1 than the difference between two squares. So, in general, if there are two numbers, n and n plus 1, 3 and 3 plus 1, 1 and 1 plus 1, then there will be 2 and non-perfect squares numbers between the squares of the numbers n and plus 1. That is 2 consecutive natural numbers. N is a natural number and n plus 1 is also a natural number. So, how many will be the numbers which are not perfect square between 14 square and 13 square? These are consecutive. The numbers will be 14 square is 196 minus 169. That is 7, 8 minus 6, that is 2, 27. So there will be 27 minus 1, that is 26 numbers between the squares of 30 numbers, less by 1. Thus, we can find out how many non-perfect numbers are there between two square numbers of consecutive numbers. N and n plus 1 are two consecutive numbers. And there will be 2 and double the numbers minus double the numbers of the natural number. Now about addition of consecutive odd numbers. Might this is a very interesting property of squares. Addition of consecutive odd numbers. Our number system, natural number system is made up of consecutive numbers, consecutive odd numbers, consecutive even numbers. Consecutive numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. But consecutive odd numbers are 1, 1, 3, 1, 3, 5, 1, 3, 5, 7, 1, 3, 5, 7, 9, like that. Serially 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, like that. Similarly, we have consecutive even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, like that. So the smallest odd number is 1, smallest even number is 2. Now here consider 1. 1 is the square of itself. 1 plus next odd number consecutive, that is 3. That gives you 4, which is the square plus 3 plus 5 equal to 9, which is nothing but square of 3. Similarly, take first 4 consecutive numbers. One number, second number, third number, fourth number. 4 consecutive numbers. First number, second number, third number, fourth number, odd numbers. 1 plus 3 plus 5 plus 7. The sum is 16, which is 4 square. We have taken 4 consecutive odd numbers and added them. And that is the sum, nothing but the square of 4. So any square can be expressed as the sum of first and odd numbers. Mind it well. Any square can be expressed as the sum of first, beginning from 1, and as many as you wish. Here, up to 3, we have 2 odd numbers. Up to 5, we have 3 odd numbers. Up to 7, we have 4 odd numbers. Up to 9, we have 5 odd numbers. Like that. The sum of first and odd numbers will always be equal to 1 square. So this is a very important and interesting property of any square. Square can be expressed as the sum of first and odd numbers. N square equal to the sum of first and odd numbers. So mind it well, they begin with 1. Now another interesting property, sum of consecutive natural numbers. Suppose you take any 2 consecutive natural numbers, they always differ by 1. The smaller number is 1 less than the large, bigger number. For example, 4 and 5. Find the sum. 9, which is the square of 3. Therefore, 4 is 3 square minus 1 divided by 2. 5 is 3 square plus 1 divided by 2. 4 is 3 square, that is 9. 9 minus 1, that is 2. 8. 8 divided by 2, that is 4. Similarly, 5. 3 square equal to 9. 9 plus 1, that is 10. 10 divided by 2, that is 5. So, we can express this interesting property of consecutive natural numbers. Another property, product of 2 consecutive odd or even numbers. We have consecutive odd numbers. We also have consecutive even numbers. What will be the product of these consecutive odd numbers or consecutive even numbers? Let us try to find out. For example, product of 11 and 13. 11 is smaller odd number. 13 is bigger odd number, differing by 1 consecutive. 11 odd, 12, 13 odd. Now the middle number is 12. So 11 is nothing but 12 minus 1. 13 is nothing but 12 plus 1. The product of these two brackets, as our algebra identity, a minus b multiplied by a plus b gives us a square minus b square. Here b is 1, so it is square of the middle number minus 1. So the square of the middle number reduced by 1 gives us the product of two consecutive odd numbers or even numbers. In general, a minus 1 into a plus 1 into a square minus 1. Now here an interesting pattern is there. An interesting pattern. 1 is the square of 1. 1, 2. 1 to 1 is the square of 11. 1, 2, 3 to 1. 1, 2, 3 to 1 is the square of 111. 1, 2, 3, 4, 3 to 1. 3 ones, yeah. 3. 4 ones. 1111. There are 4 ones. So the square will be 1, 2, 3, 4, 3, 2, 1. It is 12,34,321. The square of 1111. Square similarly, square of 1111, that is 5 ones, will be 1, 2, 3, 4, 5, 4, 3, 2, 1, increasing and decreasing. This is an interesting pattern to find out the square of the number in which all places, units place, ones place, tens place, hundreds place, thousands place, are occupied by 1. So try to understand this, practice and enjoy.